Hello and welcome. Today we'll be solving Leetcode 146 LRU cache. The question says, design a data structure that follows the constraints of a least recently used cache. Now, for this data structure class, we are going to implement three different functions. So the first one would be to just initialize the LRU cache with a positive size capacity. Then the second function is called get. It returns an integer and takes as input a key. And the way it functions is it returns the value of the key if the key exists. Other than that, it will just return -1. Okay. And the last function called put takes as input a key and a value. And it essentially updates the key with a given input value if the key already exists in whatever data structure we implemented. Otherwise, it would add the key value pair to our data structure representing the cache. And even more important information here is if the number of keys exceeds the capacity from this operation, we want to evict the least recently used key. It goes on to say the functions get and put must run in O of 1 average time. So they must run in constant time. Okay, let's look at those functions get and put again. So we get what happens is we are given an input, which is a key, and we want to just look through our data structure and determine if the key exists, right? If it exists, we return value. If not, we return -1. So in that operation, what we are doing is we are searching, right? And it's telling us here on this line that that search operation should run in constant time or O of 1 time. Okay, now let's look at the put. Similar thing is happening. We are given two inputs this time, a key and a value. And if the key exists, we are updating it with the input value. If not, we want to add that key value pair to the cache. And that must happen in O of 1 time as well. So similarly, we are doing a search and doing some manipulations after the search. So knowing that we need to do a search and it should happen in constant time, we know that we are going to use some sort of dictionary because that data structure is more suited for that operation. Okay, now back to the very beginning of the question. It says the data structure we are implementing needs to follow the constraints of a least recently used cache. So what is a least recently used cache? It's essentially a data structure that stores the data or the items that have been used more recently towards the end of the data structure. So more towards the end, we'll have the ones that are more used, and towards the beginning will be the ones that are least used, right? So hence the name least recently used cache. So if we go to the beginning, we are going to the front of the data structure, we are going to find the one that is least used. And if we want the one that has been used more recently, that is always going to be at the back of the data structure. Okay. Now with implementing the first function, it is more of initializing the cache with a positive size capacity. We'll talk a little bit more about that when we're writing the actual code. The next function, which is the get function and takes as input a key, all we are doing is we are iterating through the data structure, searching to find the key. If we find the key, we return the value. Other than that, we return -1. So if key exists, we just want to return its value. Else, we want to return -1. Right? That's fairly straightforward. Since we are using this get function and we are actually sort of interacting with the data in our cache, assuming we have our first conditional actually return a value, we want to be able to move that key towards the end of our data structure. Why? Because that key value pair we just worked on has been recently used. So want to, if this operation of checking to see if the key exists executes and return the value, want to move the key to the end right here. Very important. Okay, moving on, we'll look at the next function, which is the put. Takes as input a key and a value, and what it does is we want to update the key if the key exists. So we'll update key if it exists, right? Otherwise we want to add the key value pair to the cache. So that's the else case scenario where we will just add the key value pair. Right. Now, from the example we had earlier with the get function, we noticed that we, after operating on it, we move that key value pair to the end, right? To the end of our data structure here. How would that apply to this function? So with this function, for the first part where we update the key with the value if it exists, that is essentially interacting with that piece of data, right? So when that happens, we want to move the key to the end as well. And in the else case scenario where we just add a key value pair, the way the order that works essentially is that it keeps track of all data that is added to it. So if we have the scenario where the else case runs and the key value pair we are adding is new to our data structure, it will automatically go to the end of it. So we don't need to repeat this function here, right? And then at the end, it says if the keys exceed the capacity from the operation, we want to evict the least recently used, right? So with that case, it is a matter of writing a simple condition to check if our current size has exceeded the given capacity. And if it has, we want to evict the least recently used key, right? So since we know that the ones that are more used are always towards the front, we know that the ones that are more used are always going to be towards here, and the ones that are least used are going to be here. In the condition where we need to evict the least recently used, we will just evict whatever is right at the beginning, and that is how we solve the question. Now, two important things. We are using an ordered dict because, like I mentioned before, it is able to keep track of new data that we add. The second thing is the ordered dict data structure comes with a very unique method, which is the move to end. And the way it works is essentially when you give it the as parameter a key, it just moves that key to the end. So that is the method we'll be using as whenever we have to run this situation of moving a key to the end. Yeah, so I'll just go ahead and write a code for it. So we are just going to continue writing a code for this. Let's start with the very first one, which is to initialize the cache with the positive size capacity. So we are going to do that by just making sure that when we refer to self.capacity, it correctly matches the capacity that we're given. And we also want to initialize a cache and make it an ordered dict like we spoke about before. And now to the second function, which is the get function. We are given as input a key, and we just want to return the value associated with that key if it is in the data structure, or -1 otherwise. So we'll say if the key is in self.cache, we want to return the self.cache at that key, so that returns the value. else, in the else case scenario, we just want to return -1, like we spoke about earlier. But you remember that with the get, we mentioned that if we work on a data structure, we want to be able to move that particular data towards the end of our other date. So when we find out the keys in the cache, before we even return the value associated with the key, we want to move that particular key to the end of our other dict, right? So that fulfills all the requirement for the get, and we want to proceed to output function, which updates the value of the key if the key exists. Otherwise, it will add a key value pair to the cache. Okay, so very similar. We are going to say if the key is in self.cache, we want to update the value for that key and give it a new value that was added as an input. In the else case scenario, we are essentially adding a new key value pair to our other date, right? So we'll say self.cache at the new key should be equal to this new value, right? But before we even move on, another thing to realize is that if we run this, we are essentially modifying some data that we put in already. So it is essential that we move that data towards the end of our LRU cache, just to follow what we've already been doing. So right after updating the value here, we want to say self.cache. We are applying the move to end method to it. Nice. Now we want to pay particular attention to the end of our question here. It says if the number of keys exceeds the capacity from this operation, we want to evict the least recently used. So if we determine that the keys exceed our capacity, we want to evict whatever is at the front of the other dict, right? Because we've already established that the most recently operated on or used data would be at the end. So if we're in a scenario where we ever needed to remove the least one, we know it would be at the front. So after running this operation, we say if the length of the cache is greater than the capacity, we want to remove the first thing in our dictionary. The way we can do that is to use the pop item method. So what this does essentially is that it's going to remove the first thing in our dictionary. Usually when you pop an item, it removes the last thing in it, but then when we specify here that we want the last to be equal to false, then it knows to remove the first thing instead. The second thing I want to address is that right here, you realize that even after we add a new key value pair, we don't necessarily have to apply this move to end as well, because the way the other date works is that it keeps track of everything being added to it. So when the key and value are added, it is going to be at the end. So there's no need to add the move to end. So let's go ahead and run it. And submit. Yeah. Feel free to leave any questions or suggestions, and please let me know how I can help make your learning journey even better. Thank you and have a good day.